Oh, we have really sparse attendance today. I think most folks are on.
Think people already headed out?
Probably.
Well, let's get started anyways. John, I know that you wanted to talk about namespace for service entries. Is that still?
You did say you were going to put something on the agenda. I forget what it was.
So I'm showing the agenda now. There's namespace for service entries. I think the issue was that service entries are showing up in the default namespace.
Yeah. That's right. In the telemetry, correct. Right. The namespace is showing up literally as default.
Yeah. So did we get any resolution in the issue about, or was there any more discussion there? I hadn't been following.
Last I looked, there wasn't hardly any discussion. If somebody did a +1 on it, they said it was a good idea to change it.
So I think it would be reasonable to spend just a few minutes explaining the issue. I mean, we have many of the stakeholders here. Maybe it would be. I think it would be a good use of time.
Okay. So I've linked, the bug is linked. I don't know if people can see how. John, do you want to give a summary, or do you want me to, or fine?
I can give a summary if.
Okay.
I mean, it's real simple, right? You have traffic going to a service entry where I was using mesh external, but I believe it'd probably be the same no matter what the location is. But the telemetry that's got collected that you'll see stored in, say, Prometheus, the namespace, the destination namespace, destination service namespace, I think what it was, is literally set to default. Regardless of where the service entry resource is or where the request came from, the namespace is always default.
And I think this is because in Pilot's Mixer plugin, when it's generating this service information to go into the Envoy config, if it doesn't know, or for service entries, it sets default as the namespace. So I think that's where the source of that data is.
And then one suggestion was to set it to empty, or to set it to
external.
External.
Set it to something. Set it to something that's not a valid namespace name, right? Default is the default namespace in Kubernetes, so that's bad. I made the suggestion of putting an underscore in there because underscores are invalid characters for namespaces. So, you know, underscore service entry, or I don't know, underscore none, because it's really no namespace, right?
Right.
So underscore none would be valid. I mean, I'll leave it up to you guys.
Yeah, namespace doesn't apply here because it could be, could be anything.
Yeah, right.
What's the story for cluster scope resources? There's no namespace there anyways, so it's not just service entries.
Did you find the issue number? I can't find the issue for some reason.
It's 10174.
Yeah, it's okay, so
I'd be fine with external but I mean, I don't know if that doesn't work for mesh internal.
Yeah, that doesn't work for mesh internal.
Maybe not it in the whole.
I think it needs to have some value.
Yeah, like why does it need to have some value? Because the host name and like the other parts of service entry are actually more relevant there, right? The what namespace it belongs to, or what the name of the service entry is, and all that is not really relevant, and we don't want to draw attention to that.
The thing is, it doesn't belong to any namespace. It's a cluster scope resource.
So if you don't set it to anything, depending on the config for the instances, it'll become unknown in the metrics and things, which maybe that's okay. I don't know if you want to distinguish between just we couldn't find a value for it and this is a service entry or not. And that would be the only reason to set it to a value, it seems.
My thing against unknown is that unknown namespace makes it seem like we don't know what namespace it is, but it's in some namespace. We just don't know what it is. But that's not actually true, right? It's in no namespace. It's not any namespace.
Right.
We could write it like in /a or
Yeah, right. And /a would be a good one, right?
something.
But so okay, so then what about the general question of any other resources that are cluster scoped? Or is it going to be on a case-by-case basis? Right? It also depends on how it's used and what are we trying to convey.
It also depends on the choices of service entry and virtual services, whether they want to belong to namespace or not. I think virtual service is also cluster scoped.
Virtual service also cluster scoped.
Does that get transmitted in attributes anywhere though?
No.
So, but it might need to, and then we have the same issue. We don't know namespace.
Yeah. Do we care about distinguishing service entries from virtual services and attributes? Like, do we want to flag it out, be able to just select out on
So
service entries?
I think that from a mesh type of visualization perspective, probably no, because the destination is what really matters in these cases. But from debugging perspective, yes, right? Like if you want to know why is this going here, and then you say, oh, it's because of this service entry, or because of this virtual service, then that information is useful. But to just know what is going on, I don't think that's, like just the host or whatever the actual destination is more important.
So if we use like __ service entry _ or something, is that useful based on that?
I would just not set it, because that's closer to what it means.
Yeah, I'm just concerned that it leads to unknowns.
Yeah, that's what my concern was. If somehow it was like a blank string somewhere downstream, doesn't it like an actual default value will get used? I mean, you guys know the code, right?
Or like __ cluster or something like that, or __ mesh, something to denote that either namespace doesn't exist or doesn't apply to this.
Right.
But so the reason why I don't like external anymore is because it says a specific thing when we actually don't want to say anything specific. We just want to say that, okay, there is no namespace involved here.
Yeah. I think my example external, let's throw that away because even the service entry could be mesh internal.
Mesh internal, correct, yeah.
Right. So, yeah, get rid of _ external, but just make it something.
Okay.
So then I would say, I think __ cluster or mesh or something to that effect would be, So we should.
Now I don't know what other value, like what other use cases are there? Would this namespace be like none? Like, is there anything else?
Virtual service?
Virtual service, I don't know what other things.
Yeah.
I'm only bringing it up because maybe this _ value could actually be different values based on what the destination is.
Yeah. Yeah, although it's weird because do we want to use destination service namespace as a way to determine whether or not something's a service entry? Do we want information passed? Or do we want a different attribute?
Yeah, I don't know.
I don't think we want to add any more attributes to the time series. to be honest.
Yeah,
We had another
I'd agree with
dimension to, yeah.
that. Okay. Well, why don't we? We identified there are like 3 lines of code where this is, right? So we can write maybe a PR and have the discussion on the PR over naming. Does that sound? Sorry.
I identified the places where I thought this would change. I may have missed places, right? So don't just go by where I think the code change needs to be made.
Oh, okay. I thought that, yeah, okay, well, yeah, so we need to take an action to follow up on this. Does anyone want to own this?
Go on, can you
Sure.
do that? Thanks.
All right. Okay. The next thing on the agenda is related. There was a pull request that wanted to add gRPC status codes and messages to all the metric instances. And I sort of said, hey, hold on, let's talk about this. So I don't know if people have looked through the PR. I push back on messages in general because they have an unknown cardinality, right? It's basically infinite.
Yeah, what's the PR?
It's 10.127. So I think the real question is, what do we want to do with response code? Do we want to use the same response code label and then have it take from gRPC status code when it's a gRPC message, or do we want to maybe separate out different instances, gRPC or HTTP, based on whether or not the context protocol is gRPC or HTTP? What do people think?
So response code would include, would be changed to HTTP like response codes or no?
So that's another option, is we could add a way, maybe an expression that converts gRPC to HTTP status codes. It seems strange to me to have 2 response code labels where most of the time it won't be used for one.
It's also confusing to put HTTP code when it's actually 200.
Right.
Well, yeah, I mean, gRPC will. So if we treat response code as the semantic response, then yeah, we should just put it into the response code. But now it's a mixture of normal HTTP codes and gRPC codes, right? That's the. So adding message to metric is a problem. What's that comment? I didn't.
That's why it's unbound. The status message, your response message could be anything, right?
Oh yeah.
So I don't want to add that to the metrics.
Yeah, it should be just code.
Correct. Yeah.
Is the response code unbounded?
No.
Okay.
But they're different from the HTTP codes.
Right.
And so then
Right.
I don't know how we should overlay them. If we should overlay them, or if we should have separate metrics.
We can translate gRPC code to a string and then take a union.
Yeah, but that's what the union is like. So, for example, we can do things like the quality checks and non-200 and things like that, right? All those expressions will not be valid anymore. So, for example, we use expressions like code is not equal to 200 to mean, okay, there is some error in here and do something. Now, it would be that plus like some okay messages and other gRPC errors. So gRPC to HTTP translation is possible, but it's lossy. Right?
It's also very confusing. If you get error codes in telemetry when it's actually 200, it's going to confuse everyone.
No. So I'm saying that at that time we will change the response code and we will unroll the gRPC response code, translate it into HTTP, and set the response code. So if there was a gRPC error, it will show up in response code.
Yeah, I understand, but there's actual response code, and then there's a gRPC code within that code, right? That's how gRPC is layered. So when gRPC sends an error, it's actually response 200 with a message containing the error.
Yeah. I don't care about the response 200 because that's not very useful.
It's not useful, but it's confusing if you're going to have telemetry saying it's not 200, but it's actually 200, because it's going to be conflicting places.
But it really wasn't 200. Like semantically, it wasn't 200, right? Like that request resulted in an error, and it wasn't 200. The fact that it's shoving everything into the same response and always having the envelope show 200 and then
Yeah, I know. It's bound to cause error because like, Envoy doesn't really treat it as error, and might be other cases like that when some other system doesn't really see it as an error because the response code is 200.
I mean that, yeah, it should really see it as an error. That I think that has been raised as an issue. Okay, so I mean, looks like this has to be litigated a bit more offline, right? There is no.
Okay.
But there are clear. Can we just list the top options so that there is something to go on?
All right. So no message.
Yeah, no message. I think that we agree on.
And then it's convert gRPC to HTTP or
add a gRPC field. I suppose that's the PR, right?
Yeah.
Look at that
Or
functions. Look at that mixer functions. Just check if it's okay. That is,
yeah.
can work with both HTTP and gRPC codes.
Yes, so mixer functions would help there, but they don't actually help on the metric side. Like once you have the data, if you want your expressions to work and mean the same thing,
you can use an expression, the function that help. So instead of putting equals 0 or equals to 100, you can just say, is it okay?
No, but you can't do that in Prometheus. Like once the data is in Prometheus,
right?
You can't say is okay.
Maybe give it a choice. Make add a function that translates gRPC to HTTP, and then instance itself would make a choice.
Yeah, okay. That's another option. So we don't do that automatically, but okay. So someone needs to own this.
I can push the doc out. Okay. The next item on the agenda was update on the server side check cache issues. Kawat, did you want to maybe just fill us in on?
Yeah, I can tell the problem there is that our server-side cache was ignoring certain values in computing the check key. So that led to false hits. And the solution is to, at least for the short term, is to disable the server-side check cache. And the long-term plan is to fix the values inside Mixer that we always consistent with types what we expect. And after that, we're going to try to make sure that the cache actually works. The surface level effect was that if you used anything like string map or net IP, it would not use it as a check key. If the expression referenced one of those things, then it would not be treated as such.
So this has been disabled in 105 or what will be 105 very soon. Is Does anyone think that they are going to be affected? Like I think that Scott, your adapter would be affected by the fact that there is no mixer side cache sitting in front of it.
Scott on. Oh, he's on.
I am on, but unfortunately, I haven't quite caught up.
Oh, so okay. There is a server side cache on Mixer, and we had to disable it in 105 for some
Right.
correctness issues. So the
Right.
question is, that means whatever cache, whenever it was hitting the cache and it wasn't calling your adapter, now it's not going to do that. So how big of a performance issue is it going to be for you?
Oh, I see. I was. It shouldn't be. It shouldn't be bad.
Okay, that's.
I have internal caches as well.
Oh, okay, all right. That's good then. That's very good. All right.
Okay. Okay. I put on perf update, but I see that you've added a bunch of stuff below. Do you want to talk about it
Yeah, sure.
then or later?
Actually, I can talk about that later. You can.
Okay. I'll get rid of that then. There are some. I can link here in a second. There have been lots of reports that have come in from a couple of users about metrics having duplicate labels in Prometheus, and this stops all collection of labels. And we couldn't figure out how this was happening. It seemed to be impossible. But just this morning, I was able to take the Prometheus client library and I changed one of their unit tests, and I was able to reproduce the issue. So I think hopefully within the next couple of days, there'll be some more news here. But up until now, we haven't been able to reproduce it, but I'm finally able to reproduce it. So all I can say is stay tuned.
So just so that everyone is aware, right? This issue also has like a poisoning effect on the registry. So once it happens, like collection either stops or cannot proceed. So it's not just like one request hits this issue and it's done, but once it hits this issue, yeah, the metrics collection as a whole stops working correctly. So this is extremely important for us to find a solution.
So anyways, thanks for the patience, I guess, on that. The other thing I wanted to bring up was there was a blog on IP whitelisting, and there were a couple issues raised in IP whitelisting in terms of support for net.ip and IP address as a value type, which I think some of the work that you've been doing, Quat, might actually touch on, because we'll have consistent use of NetIP.
Yeah, so we actually had support for NetIP. It's just we were using byte array and uint array interchangeably, which they're not, and we need to pick one and just to go it.
So there's some work there, and then the other thing that was, there were two issues. It was that, and oh no, why am I blanking on this? Do you guys remember?
On the whitelist one? Since you have been following it,
Well, anyways, so I think some of the outcomes I don't know if anyone here uses IP whitelisting, but that we need a task and an FAQ and a sort of more documentation of how to use list checker. Because this is apparently, enough people are trying to use Istio, but it was the response codes. We return 404s when things aren't in the lists, which might be okay if we were saying we're trying to hide the fact that we're using a list, but we also return a message that says you're not part of this list. So I think the question is we have to resolve whether or not we want to return 403s or 404s when whitelisting or exclusion list fails. So
yes, we definitely need to fix that.
Response code. I'm gonna assign this to Martin. Since he's not here.
Yeah.
But anyways, I just wanted to update everyone on that. And then do you want to talk about?
Yeah. So in our performance testing, right, like large scale cluster testing, in 1.1 we first observed this issue of like mixer go routine growth, and then eventually it goes out of memory, and it happens. It doesn't always happen, but it does happen kind of often enough for it to be a concern. And I found several different issues. I've listed them in the notes, but essentially everything boils down to excessive contention on some common resource. And one of the final things that we found was Prometheus Registry itself, right, the way Prometheus collects metrics, is written in such a way that it does not deal with too many go routines trying to add to the registry well. And it can very easily get into a situation where it's not deadlocked, but it just grinds to like a crawl. And then once that starts happening at the back, since we don't really have any back pressure mechanism in Mixer yet, we keep on accepting more work from the front. And now Prometheus adapter has kind of ground to a crawl. And now it's just a vicious cycle. Now go routines continue growing, memory continues to grow, and we go out of memory. So I have a fix from our side on that, on the way Prometheus Registry is used. And then we also have ideas about kind of optimizing that further or making that better. A similar issue, again, excessive contention issue, was also observed in Jaeger trace generation. And it was attempting to create a random number. And in order to create a random number, it was attempting to grab a lock. And if you have 5,000 go routines all trying to do that, then that doesn't end well. So again, they were somewhat related, but but there was a common theme. One other thing I observed, and that may have been like a secondary observation based on some other bad things that were already happening in the system. But however, the attribute bag itself is pooled. We don't create a new one. We put them in a pool. And the way sync pool works is that, I mean, it's just another lock, right? You just grab a lock and you say, I want something from the pool, and then you get it from the pool. And again, when there are a lot of go routines, and especially when that pool is shared between the front-end go routines, which are unbounded, which are spawned by gRPC, and then we have a pool of go routines in the middle, right? So both those classes of go routines are contending on the same lock to check out something from the from the back pool, and that also led to enormous contention. So again, I did a local fix, but that fix we have to revisit and see once the other things are fixed, is that still an issue? But it does seem like it. We either should not use a pool or use separate pools for different classes of go routines. And again, the fact that we don't apply any real back pressure. So now we have load shedding, which can be converted into back pressure, but we don't have that completely done yet, and that's something that we do need to complete. So that's where it is at, and again, this has taken a lot of time to kind of unearth all these different issues.
Okay. I think you're next on the agenda again with V2.
Yeah, so I just wanted to check if people have had time to go through the document that Martin sent last week, or what. So he did send out both the kind of the design, or design doc, and also a presentation about this whole Mixer V2 work. What I will do is I will just kind of quickly go through what it is, and then as people have more questions, I mean, we can either answer them now, or I encourage everyone to go back to the doc and add more comments there. So let me.
Do you want me to present one of these?
Yeah, so ooh. Okay, sorry.
Can you present?
Yeah.
I just linked these in the agenda doc in case anyone was looking for them.
So one of the critiques of Mixer V1, well, our Mixer, right, as it stands today, was that there is management overhead. Like you need to manage this one other thing. There is also latency cost involved. Sometimes even after you account for the cache hit rate, there is most definitely tail latency when there is a cache miss. And then general concerns about single point of failure, right? So when we thought about, okay, so what can be done to address some of these issues, right? One of the obvious solutions was to move as much as processing as possible, right, from this component that lives separately into Envoy itself. So essentially, what Mixer V2 is you can think of it as Mixer in Envoy. In addition to that, we have also decided that we should go for a simplified configuration model, and all that really means is every adapter now gets to define its template like very precisely. So there is no mapping or try to match some other template or anything like that, right? If you are Prometheus adapter and you need your input in a very specific form, well, that's what you should use, and then that's what you'll get. And then the new features that are possible are protocol capture. So we've had this long-running thing about direct API and how we deal with telemetry, and then even it was mostly related to telemetry, but how we deal with a service directly calling something or directly sending some telemetry data, and how do we capture that? How do we insert it back into the pipeline so that we can do the normal stuff that we do? So that's kind of made possible or easier by this Mixer V2 model. And then payload mutation. Previously, because Mixer was since today Mixer is outside, mutating payload is not that simple, right? We actually we have several proposals which are all kind of very complicated, of either having a stream go out to somewhere else, it's mutated and comes back, or you have to buffer. So having Mixer functionality inside Envoy itself means that you can now mutate payloads. So in many ways, Mixer now becomes this very configurable and flexible, but still portable filter chain extension. I mean, which it was before too, But now it's kind of more, it's clearer that yes, it runs inside Envoy, and it is a way to write new, add new functionality in a much easier way. So again, if you go through the value proposition, it's again we can collect rich telemetry. Now, some of this is already true today, so it's not completely new, but the latency, single point of failure, and the other two things, right? Protocol capture and payload mutation are kind of completely new things that are possible. This is how the transformation pipeline looks. So we now have this concept of an ingestion adapter, and all that really is it will take input from something. Right now, so far you can think of what we have today as like the Envoy ingestion adapter, which is Mixer client, right? So what it does is it takes as input, sitting in the Envoy filter chain, it takes as input whatever Envoy has to offer, headers and other metadata and things like that. And then it converts that into attributes. So that's the first kind of level. That's today's ingestion adapter, and we just have one. So now we have formalized it, and we can now have many other kinds of ingestion adapters. So this is where the direct API comes in, right? So for example, we can have an ingestion adapter that understands statst on the wire, and then it reads statst from one end and then converts it into a proto that now can enter the pipeline again. So this is simply showing that you get the ingestion adapter, you transform it, then you dispatch it, where you decide what you like, which backend adapters you need to send that to, and then the backend adapter, which are like today's adapters really, it can contact backends that are outside, or they can do something locally. And then the additional part is the arrow that goes back. So being able to rerun part of the filter chain or the entire filter chain is also going to be part of this work. Now, Envoy supports some of this today, and it doesn't really support some of this today. Like, you can't actually really fully rerun the filter chain. So today you can just ask Envoy to reevaluate the route. You can't actually rerun the whole filter chain and go back, but there are.
You can if you don't have body identity situation.
If you don't have body, yeah. So once we have this whole thing working, you can actually go back and transform something more. So it is a lot more flexible than what we had before. So in order to do this, what we are going to do is write Mixer functionality, port it into C++, and run it inside Envoy, right? So today's Mixer client filter will actually just become Mixer, right? I mean, it will take its place, so to speak. So let me see. Okay, so yeah, this is an example of how the new system will look like. There's the Envoy filter chain. Now we already have a precondition adapter, which is called once we decode headers, right? And that largely looks the same, right? I mean, only the boundaries are redrawn here, with the caveat that now you can go in the loop and ask it to rerun and reevaluate route. Mutation adapter actually operates on the body, so it gets called back when more actual data is read. And there again, you can do something similar. You can read the body, send it out to somewhere, get it inspected, and decide to go forward or not. And then the telemetry adapter, which happens at the log level, which happens at the log callback, which is at the very end of the filter chain. And then on the right-hand side, we have this workload directly trying to go out to someplace, right? So let's say in this case, we give an example of stack driver adapter. So it's the workload is directly calling stack driver in the stack driver format, and then inside the filter chain, we're able to capture that, transform it into something. And again, the second part is all configuration driven. And then based on that configuration, decide what other adapters need to be called, transform it back into whatever stats-t, and in this case, we also show Jaeger want, and then they go out to their respective backends. In terms of user model, I think the only thing new here is that there is two-way pipeline now, right? You can have some circles. This is how physically it is going to look, and some of this is evolving. And of course, we would love input here of like what people think and all that, because this is still kind of somewhat early days. But essentially, Mixer itself runs as a library inside Envoy. It has these ingestion adapters and backend adapters. And then, of course, all those can also be outside as well, right? Not everything needs to be inside. To begin with, what we will do is we will implement Mixer frontend and the gRPC dispatch, right? So essentially, we will have Mixer functionality and the ability to call gRPC adapters, all part of the Mixer filter itself. And so that way we can use all our existing gRPC adapters, and now rather than Mixer calling them, Envoy calls them directly. As the next step, we can actually start moving some of those adapters back into Envoy. And there are, so that's a bit more involved, but here's the general idea. There is Envoy, then there is some platform abstraction layer. Platform abstraction layer is going to abstract some of the Envoy specific filter chain things and make it more portable. And then there is the Mixer portable library, which is built on top of this abstraction layer. And then there are portable but built-in adapters. And we, like I said, we're going to start with gRPC. And then there is a very good chance that we'll also have a built-in Prometheus one, because it's just so heavily used already. And the common things that the platform abstraction layer gives us is managing network connections. So actually, if you look at, if anyone is familiar with the Lua API and of Envoy and the Lua filter, right? This does borrow a lot from kind of that model generally, that you have a very specific way to reach out to other places. So network connections, because that's kind of purpose of Envoy. So Envoy manages all that. And then you should be able to schedule some asynchronous work, manage some timers and all that. So that's the abstraction layer. The specifics of the API and those proposals will come, and everyone will get a chance to kind of comment on that as well. And here is where, so we haven't talked about this a lot before, but here's where it gets a little bit more interesting. So what we eventually want to do, and what Envoy is going to support in a quarter for sure, is the ability to load WebAssembly adapters. what that means is once this is upstreamed, we can just have the stock Envoy as Istio proxy, and we will use effectively XDS or some other similar mechanism to send WebAssembly code to Envoy, which it can load as and when needed. So there won't be any need to have a custom build of Envoy. We can just use the Envoy that we have and then load WebAssembly through here. The reason why we have this portable layer and the platform abstraction layer and all that is because that helps us create a sandbox, which is essentially what WebAssembly requires and gives you. So once you program to that API, we can actually write the code in several different languages. Many languages support targeting WebAssembly as the architecture. It's just an instruction set, like a higher level instruction set than kind of a normal assembly. But you can write your code in C++ or Go or Rust or ASM.js and several others, and then all of that can be targeted to WebAssembly. We're going to start off by just mix it in C++, which it will move into WebAssembly like this. But eventually, we can start moving specific filters, right? Specific mixer adapters that are written to a slightly different API. And even they can migrate directly into Envoy, kind of managed by the mixer adapter there. So in the beginning, we will support both of these types of deployments where we have gRPC adapters that are running outside, and all of them are called from Envoy. And as and when needed, and as and when performance needs dictate, we will have adapters that actually, with some change, migrate into Envoy itself and kind of get more benefits that way. So that's kind of the ultimate picture here of we start with a stock Envoy, and then these new behaviors get loaded into Envoy through WebAssembly. That's it. And yeah, and there are, and I can, so I think there are some links here, but I will add some more links in the meeting note about WebAssembly specifically.
Are there any questions? Is any comments, or people still trying to digest? Okay.
All right. Looks like everyone loves it.
Is there any other issues that people want to bring up this week? It's probably be, well, let's see, what's it, the 5th today? Second to last meeting of the year of 2018. Is there anything that anyone wants addressed before the end of the year? Probably be a good time to bring it up.
So the next one is going to be 20th, right? Yeah. Okay.
All right. Well, thanks for listening, everyone. And follow along on the issues, I guess, and more details about all the new architecture proposals will follow as well.
Right. Thank you.
Thanks, everyone.